good day to everyone. In this topic video, we're going to take a look at an important marketing concept. It's called the elasticity of demand and supply. Okay, so what is elasticity?
So, elasticity is all about the sensitivity or the responsiveness of demand to a change in a variable. And price elasticity of demand measures the extent to which the quantity demanded changes in response to a change in price.
Hi guys, welcome back. The arc elasticity of demand is one of the methods of calculating the price elasticity of demand. When the price elasticity of demand is to be calculated between 2 points on the demand curve, then we use your arc elasticity method. In the given figure, the 2 points are your point A and point B, and if we want to calculate the price elasticity between these points on the demand curve, then we use your arc elasticity method. Now the formula for calculating the elasticity by arc elasticity method is very similar to your percentage method or the proportionate method of calculating the elasticity. So the formula for your proportionate method was as follows: percentage change in quantity demanded divided by the percentage change in price, which was written as the change in quantity divided by your original quantity divided by the change in price divided by the original price. Now in arc elasticity method, instead of using the original quantity or the original price as base, we use the average price, the average quantity or the average price, or the midpoint of the two quantities or the midpoint of the two price. So the formula for your arc elasticity goes as follows: change in quantity divided by the average quantity, which is the original quantity plus change quantity divided by 2, again divided by your change in price divided by the average price, which is again your original price plus the changed price divided by 2. So why do we use this average instead of original? Let's find out with the help of an example. Let's say there is a commodity X whose original price was P1, and in that price the quantity demanded was Q1, which is 40. Now let's say the price decreased to P2 to 8 and the quantity demanded it increased to 60. Now let's try to find the elasticity between these points by using your proportionate or percentage method. So the formula is your change in quantity, which is 60 minus 40, 20, divided by your original quantity. So we are taking these as your original quantity right now. Yes, overall divided by the change in price, which is 2, 10 minus 8, divided by your original price, which is 10. So this will give you 2.5. So the coefficient of price elasticity is 2.5. Now let's say in the same example again the price increased back to 10. So the price it again increased back to 10 and the quantity it again decreased back to 40. So now let us again find the elasticity for the increased price. So now we have to keep these two quantities as your original, as your base, because now we are calculating the elasticity for change from this point to this point, right? So let's find out the elasticity once again. So the change in quantity will remain the same, it is a 20, divided by the original quantity will now be 60, because we are taking these as your base, right? Divided by the change in price will again be the same, it is 2, but the original price will take as 8. So this will give you the elasticity 1.32. So you see previously we got the elasticity 2.5, right? Now we are getting 1.32. So for the same data we are getting two elasticities, two coefficient of price elasticities, because one is for the increase in price and one is for the decrease in price. But does it seem correct to you that for the same set of data you cannot get two price elasticities, right? It will create you a lot of confusion. So in order to avoid that confusion, we use the average method in your arc elasticity of demand. So in your average method, whether there is increase in price or decrease in price, for the same set of data, you will get only one elasticity, only one coefficient of price elasticity. That's why this method is more scientific and more convenient. Now for the same data, now let us find the arc elasticity of demand by your midpoint method. So let us first find out the midpoint of the quantity. Let's call it QA, the average quantity. That would be your 60 plus 40 divided by 2. It's 100 divided by 2 will give you 50. And your average price, P average, would be your 10 plus 8 divided by 2, which is 18 divided by 2, which gives you 9. Now the coefficient of price elasticity, of arc elasticity, would be change in quantity, 60 minus 40, divided by your average quantity, divided by the change in price, divided by the average price. So this would give you the coefficient 1.81. So this is the arc elasticity of demand. Now let's talk about the point elasticity of demand. Now it is yet another method of calculating the price elasticity of demand. When the price elasticity is to be calculated at any point on the demand curve, we use the point elasticity method. Now let's say we want to calculate the price elasticity at this point. Let's call it S. So the formula for calculating your point elasticity is the lower segment divided by the upper segment. Now for point S, the lower segment would be your ST and the upper segment would be your S and small t. Right, so the lower segment would be S capital T and the upper segment would be ST. Now let's say that the whole demand curve, it is 8 centimeters in length and the lower segment is 2 centimeter and the upper segment is 6 centimeter. So your point elasticity at point S would be your 2 divided by 6, that is your 0.33. Now again, let's say that you want to calculate the point elasticity at your midpoint R. Now at midpoint R, your lower segment would be equal to your upper segment, right? RT divided by RT. So since these both segments are equal, you will get the point elasticity 1. So what can we understand from here is, at midpoint, the price elasticity would always be 1, and as we move towards the lowest part, lower from the midpoint, your point elasticity, it gets lesser than 1. Because as we move lower, the lower segment is lesser than your upper segment. And as we move upwards, the point elasticity would be greater than 1, because again, the lower segment would be greater than your upper segment. And at this end point, at capital T, your point elasticity would be 0, because at this point there is no lower segment. And at this point, your small t, the point elasticity would be infinity, because then there is no upper segment. The upper segment would be 0, and anything divided by 0 would give you infinity. So now let's look at this figure. You see at midpoint, the point elasticity is 1, and as we move lower, the point elasticity becomes lesser than 1. At the lowest point, your point elasticity is 0. As we're moving upwards the midpoint, the point elasticity is greater than 1, and at the highest point, the point elasticity is infinity. So guys, this was all about your arc elasticity and the point elasticity. I hope you've understood them both, and if you found the video useful, then please subscribe to the channel for more content on different topics of economics.
Income elasticity of demand, shortened to YED, measures the responsiveness of consumer demand to a change in income. The equation to calculate the coefficient of YED is YED equals the percentage change in quantity demanded over the percentage change in income. For example, if income rises by 5% in a year, and the demand for clothing increases by 10%, then the YED for clothing is plus 2.0. The result is a positive one. As income rises, so does the demand for clothing, in this case by a greater proportion than the increase in income. However, if demand for bread falls by 20% following an increase in income of 5%, the YED for bread over the relevant income range is minus 4. In the case of bread, the result is a negative one. Goods where the relationship is positive are called normal goods, and inferior when the relationship is inverse. However, there is another aspect to income elasticity, exactly how responsive, that is, how elastic, demand is to a change in income. Economists use the concept of proportionate to compare responses. For example, if the demand for a product changes in exactly the same proportion as income changes, then the result is proportionate, and YED will equal 1. If it does, then YED is said to be unitary. When the coefficient is less than 1, the YED is inelastic, and when it is greater than 1, it is elastic. So, in the case of both clothing and bread, YED is elastic, which means there is a greater proportionate response in demand to the change in income. Both goods are elastic despite having different signs. It is therefore possible to have both elastic and inelastic normal and inferior goods. For example, if the YED is plus 2.5 for smartphones and is minus 0.5 for rice, then we can deduce the smartphones are, with respect to income, an elastically demanded normal good, and rice is an inelastically demanded inferior good. Income elasticity can be visualized through Engel curves. Here we can see that Engel curve A slopes upwards, and it is steep, which indicates that the quantity demanded for good A changes by a smaller proportion than income, indicating that it is a normal good with an inelastic YED. Engel curve B also slopes upward, indicating it is a normal good, but the gradient is much flatter, indicating that the quantity demanded of good B changes by a greater proportion than income, hence YED is elastic. In this case, the good is not only normal, but is considered to be a luxury good. Finally, with Engel curve C, the gradient is downward sloping, indicating that the relationship between income and quantity demanded is inverse, and the good is an inferior good. Economists are interested in income elasticity because knowing YED helps firms and governments plan their output in such a way that they can respond effectively to demand changes and achieve an efficient use of scarce resources. For example, if a US firm produces a product to be sold in 2 countries, Germany and Japan, and its market research suggests that the YED in Germany is 2.2 and in Japan is 0.5, then the firm can predict sales following changes in consumer incomes in Germany and Japan. For example, if incomes are forecast to rise by 4% in Germany and by only 2% in Japan, then demand in Germany will increase by 8.8% and in Japan by only 1%. This is highly significant, and the firm can target more resources to the growing market in Germany. Similarly, governments will take into account YED for public goods and merit goods. For example, if the YED for motor vehicles is 3.5 and for cycles is 0.2, then, as national income grows, demand for road space will grow, with demands for roads increasing more than for cycle lanes. Using these figures, we can predict that an increase in a country's income of 2% will lead to a 7% increase in demand for motor vehicles and just a 0.4% increase in demand for cycles. This information, along with YED data for a whole range of transport forms, can help shape a government's transport policy. Clearly, information on YED is very useful in that it helps solve the problem of information failure and enables firms and governments to make more rational decisions about the best way to allocate scarce resources to competing uses.
So the next one that we're going to discuss is about cross-price elasticity of demand.
What is cross-price elasticity? Well, of course, it's an elasticity, so therefore it's about responsiveness, and this time we're focusing on the responsiveness of demand for good X, could be a good, could be a service, following a change in the price of good Y, where Y is a related good. So we're looking at cross differences in relative prices between two goods or services. Now, crucially, with cross price elasticity, we make an important distinction between substitute and complementary goods. And we'll go through some examples in this revision video. So there is, of course, a formula. So what is the formula for calculating cross price elasticity of demand? Here's the formula, always worth putting in the exam to get a mark. Cross price elasticity equals the percentage change in demand for good X divided by the percentage change in the price of good Y. And we're going to assume here that there is some relationship between good X and good Y. If there isn't, then the cross price elasticity will be zero. We make a key distinction in this elasticity between substitutes and complementary goods and services. So, what are substitutes? Well, substitutes are goods and services in competitive demand. They're competing for your spending, for your budget, for your custom. And substitutes have a positive cross-price elasticity of demand. The cross-price elasticity, XED or CPED, will be greater than zero. That means an increase in the price of one product will lead to a rise in demand for a substitute. Those are examples. Fierce competition between Pepsi and Cola and carbonated drinks, between Xbox and PlayStation and others, in games, consoles, the battle for market dominance in smartphones, and competing pizza brands from Pizza Hut to Papa John's to Domino's. Those are all good examples of substitutes in the market. These substitutes are in competitive demand. Fall in price of one product, other things being the same, will lead to a fall in demand for a substitute. Now, some products are close substitutes, others less so. A close substitute, often very similar products. There's minimum differentiation between them and often a low cost of switching if you want to change your spending. So substitutes have a positive cross price elasticity. We can just quickly visualize this in an XY space diagram. Notice we've got the price of T on the y-axis, the quantity demanded of good V on the X, where T and V are substitutes. This curve would suggest a strong substitute relationship. You see a small increase in the price of T from P1 to P2 leads to a substantial increase in the quantity demanded for V, suggesting a highly elastic, strong substitute relationship. Just look at this example. This is a weaker substitute relationship. Yes, if the price of T goes up, people buy more of V, but this time can you see a big increase in the price of T only leads to a small, relatively small increase in the quantity demanded of V. That would suggest a low positive cross-price elasticity. Now, what are complements? Well, complements are goods and services in joint demand. We tend to buy them together, and the cross-price elasticity of demand for two complements will always be negative. The sign does matter. An increase in the price of T, for example, will lead to a contraction in demand for T. People buy less T, and a fall in demand for a complementary product, good S. Examples, well, here's some good ones, I think. Smartphone and apps, hot dogs and buns, my favourite. Oh, my next favourite, nacho chips and salsa dip. Fantastic example of complementary relationships. Can you imagine having them without each other? Razor and shaving oils and other shaving products are good examples of complements. And complements have a negative cross-price elasticity. If the price of X goes down, people buy more of X, and they'll also buy more of a complement Y. And this diagram shows a fairly strong complementary relationship. If the price of X goes down from P1 to P2, the quantity demanded of Y increases quite substantially. Strong negative relationship between the price of X, demand for Y, whereas this diagram here shows a weaker relationship. A big fall in the price of X, there we go, only leads to a relatively marginal increase in the quantity demanded of Y. Well, it measures the sensitivity, or a keyword, the responsiveness of the quantity supplied of a good or service to a change in the price of that good or service. So when demand changes, the key question is whether a firm can respond by altering their output levels. Now we're focusing in this video on price elastic supply. That occurs when the coefficient of elasticity of supply, don't forget the coefficient is just a number, when that is greater than +1.